Okay, so we are on 21.
We didn't get to 20 yet. We're like halfway.
Oh, you're right. You're right. We were working on 20 and didn't finish it yet. Thank you. Yeah, thank you. Okay, so what we were doing was subtracting y squared to move things over. And so we've got 5x y squared minus y squared equal negative 7. Yeah, what we're doing is we're trying to get y on the same side, and then we're going to do our greatest common factor.
Oh, yes.
So we take out our y squared, so we get 5x minus 1 equal negative 7. Then you divide by 5x minus 1. And so remember in this problem it said x greater than 0. So when we take our square root, we really only care about the positive. So y is going to be the positive square root of negative 7 over 5x minus 1. So that answer works, but I noticed in the key they didn't do the negative on top. They changed it to be like a positive 7 and then reverse these. It is the same thing. Yeah, because you can move your negative from the top to the bottom and then distribute, and you do get the same thing. Yeah, so that's our answer. Okay, so square root of 7 over 1 minus 5x. Okay, now 21. Okay, so the easiest way to remember this, you are working inside out like we've said before, but the easiest way to remember it is to circle the ones that are closest to the number, because that's what you're going to do first. Okay, so on this one you're doing g of 4 first, and so that's going to be 20 over 4 squared plus 4. So that's really just 20 over 20, which is 1. So we got an answer of 1, and then we do f of that answer. F of 1 is the absolute value of 1, which is also 1. So you get your first answer, then plug it in to the other function, and then evaluate. So this one we're doing f of 2 first. And so you have the absolute value of 2, which is 2. Then you do g of that answer. G of 2 would be 20 over 2 squared plus 4. That's 20 over 8. And then since both of those are even, you're going to want to reduce that. In fact, they're both divisible by 4, so simplify as much as you can, and you get 5 halves. Then our next one says f of 1, so we do f of 1, so absolute value of 1, which is 1. And then you're doing f of that answer. So again, f of 1 is 1. All right, so for this one, we do g of 0 first. Don't just assume the answer is 0, because it depends on the equation that's given. This one we're doing g of 0, so that's 20 over 0 squared plus 4. which is really just 20 over 4, which is 5. And now we're going to do g of 5. So that'd be 20 over 5 squared plus 4. 20 over 25 plus 4 is 20 over 29. So none of those answers were 0. So don't fall in the trap of just because it was a certain number usually means it always is. By the way, I did make y'all's final yesterday, and it's 22 questions.
22 questions.
Yeah, instead of 36. 36 is a review.
Thank you.
You're welcome.
Yeah, I'm down.
Okay, 22. The domain and range of the function is what they want first. So basically, you just have a 0 for your vertical asymptote. So this is x not 0. Question?
Is it online or is it?
Yeah, it's still online.
Is this review due today? Yes. We're gonna finish it today.
Yeah, we'll finish it today. Yeah. You don't have to turn it in until you're taking your final. Yeah. And also remember there's a Math Excel review, so if you make at least 80, then that's an extra 3. If y'all's final is tomorrow, then it's due tonight. If y'all's final is Thursday, then it's Wednesday night. So, yeah. No, they're due the night before because you're not going to have your review available during your test. So, that's the way I'm doing it. You can use notes, yes, but not your reviews. Then you're up the creek without a paddle. You got to float. Yes. Okay. All right. So then your range of this one. There are certain places where you have your slant asymptote, but it's still defined like on this side and that side. So there's no problems with the range. There's no horizontal asymptote, and so it's going to be the one with all real numbers.
Wait, why is it the domain on this?
Because you have a vertical asymptote at x equals 0. Vertical asymptote x equals 0. So, all right, good. So then the x-intercepts, if there are any, they're the plus and minus 1. It wants an integer fraction. Use a comma to separate as needed. So negative 1 and 1. Yeah, and there's not a y-intercept. There's not a y-intercept. And again, if you need a reason for that, it's since the vertical asymptote was x equals 0. Anytime you have a vertical asymptote at the y-axis, there's no y-intercept. Just kind of makes sense. Yeah. The next one's asking about the horizontal asymptote, and there is none. So that's B. The vertical asymptote, as we've said a few times, it's 0. Yeah. Okay, then for the oblique asymptote, we've got to use the ordered pairs here. Since it goes through 0, 0, it's very easy to get the oblique asymptote. You basically are just doing your delta y over delta x, but one of them is 0, 0. So all you're really doing is 8 over 2, and you get 4 for your slope. And so based on that, it's y equal 4x. You can put plus 0, but there's really no point. So y equal 4x is what I'm going to put in this blank. So all you really have to do is y over x.
But that's only if it goes through 0.
If it goes through 0, 0, right. If you have it going through a different point, you may want to do it a different way, like I can show you real quick. This is how I teach some other classes how to do these with list and spreadsheet, and put X here, put Y here, then you put your ordered pair, and the other one was 2 and 8, and then you go to thank you, appreciate it.
Don't you have to have at least 3?
Do you have to do what?
Don't you have to have at least 3 points for that?
No. 2 works. Yeah. Any 2 points make a line. Yeah, that's okay. That's okay. And then you go menu, statistics, stat calculations, then linear regression with the MX plus B is what you want, so that's number 3. And then you can either choose X like this, or you could have just typed X. In this case, I'm just going to type Y, it's faster. Then scroll down to OK, and we get 4 for M and 0 for B, so it's 4x plus 0, which is the same as 4x. So if you have some other ordered pairs other than 0, 0, you may want to do it that way. Otherwise, use your formula. All right, so that's y equal 4x. The next one, you can go ahead and type this to see what number you work towards. Make sure that if it says pi, that on that particular problem you're in radian mode. See if it works out. If it doesn't, then you have to use the unit circle. So I'm already in radian mode, so I go 2 sine pi 6 minus 3 tan pi 4s. So you get -2. So that's the best way to do it because there's no decimal or anything. But if not, use your unit circle. And the sine of pi 6 is like the sine of 30, which we know is a half. And the tan of 45 degrees is like the tan of pi 4, and that's 1. So you're basically doing 1 minus 3. So that's how you'd have to do it if you end up with like a decimal of some sort, like involving a square root of 3. Remember, we've had several combinations of those. It just changes angles. All right, 24. This one says find your functions f and g so that it's equal to h. The first thing you do is use your outside function for f. So f has to be the square root of x because it's the outside function on the left. And then your inside function is going to be the x squared plus 9. Yes, so that's D. Okay. And then the next one, you want to analyze the graph. And so for the domain of it, remember we set our denominator equal to 0. So you could write the whole thing or simplify it and just abbreviate. Make sure you take the square root of 100 and you get both plus and minus 10. So that's going to be the C answer. And then because the numerator is just a 7, it's not x minus 7 or anything, all of these places are where your vertical asymptotes are. So you do 7 and then plus and minus 10. So just use the exact same numbers. And if you want to graph it, you can. Then it wants to know the equation of the horizontal or oblique. Well, if you ignore the 7 and 100, it would be like 7 over x cubed for what the function is. And so that means it'd be proper. So that means it's y equals 0. In fact, on every single graph, it looks like you have a horizontal asymptote at y equals 0. So if you get this question, it would be 0 for that one, based on the graphs. Yeah, the horizontal asymptote's where it gets close. Right. Okay, so then let's graph it. And there's one little trick on this, so I do want to graph it even though it'd be quicker to not. Make sure it goes in the calculator properly. And looks like you're going to have to use a double parentheses for it to work. Yeah, that's what you have to do. So use a double parentheses as you're entering in the denominator. Because if you don't, then the x squared minus 100 would just be to the side. You'd have to edit it and move it down. Okay, so this is what we want for the graph because the function matches, except for there's something really peculiar. The y values, they're just going from negative 0.34 to positive on all of them. So go to your menu, window, settings, negative 0.34. Whoops, I'm trying to do the wrong one. These should be negative 15 to 15 for all of these. Yeah, for the x's. And then the y's should be from negative 0.34 to 0.34. Now that shows you a little unusual thing here, kind of like a parabola. And the only one that matches that is this one. So let's see. All right, on 26, this one you're given your angle in degrees, and you have your radius. Your formula is S equal R theta. Remember, your theta has to be in radians. And so this would be 14 times 70 times pi over 180. If you'd rather do your theta separate, you can. It's just most people prefer doing it all in one step. I mean, this would have been 7 pi over 18. Yes, yeah, you have to change the degrees to radians. So when you type that, you get 17.1042, and it says round to 3 decimal places, so 17.104. So that's for your first part. And then for your area, it's 1/2 r squared theta, so 0.5 times 14 squared times your 70 times pi over 180. And if you type that in, you get 119.7295. And based on that 5, you have to round up. So you get 119.730. R is the radius, so it's the 14. It's half the diameter.
And then for
The angle in this case shows you the degrees.
you don't have to turn that into radians?
Well, I did all in one step by doing 70 times pi over 180 in both of them. Yeah. Yeah, if all you do is type 70 instead of the pi over 180, then you'd miss it. Okay, good. 27. This one wants you to change to an equivalent statement. So the best way to remember to do this is to bring this down. And basically the base for the exponent becomes the base for the log. So you're going to turn into log base 7 of 8.3 equal x. Or, like what the key has is the x equal in front. It should accept it either way. But don't forget the x equal, because if you just put log base 7 of 8.3, it's going to count it wrong because it wants an equation, and so that means make sure you put your equal sign. Okay, the next one, you'll need to get a common base instead of just setting those equal. And you remember 3 to the third power is 27 because 3 squared is 9. And so we're going to use those to rewrite this. So the 27 part is 3 cubed, and then we've got 5x. And the 9 part is 3 squared, and then we've got x plus 3. Now that your bases are the same, then you can just work it out. So you get 15x, bless you. And then make sure you distribute here. Don't just get 2x plus 3. You're supposed to get 2x plus 6. And then subtract, you get 13x equals 6, and then you get 6/13. Any questions? Okay. On this one, graph to see where you are, and you've got a small positive followed by a little bit larger negative. 1/4 is smaller than 1/3, but you're in this quadrant, quadrant 4. Okay, so our first step on this would be do your Pythagorean theorem. And make sure your parentheses are exactly like this for the negative 1/3. Because I know somebody accidentally would have gotten gotten negative 1/9 if you did your negative out here and then put your 1/3 in parentheses. So make sure you do it like what I'm doing. And you should get 25 over 144. This is what r squared is. And so r would be the square root of that, which is 5/12. R is 5/12. Because you're taking your square root of both the top and bottom. So this is not on the unit circle. Don't just put negative 1/3 and 1/4 and so forth. Do your Pythagorean theorem to find your radius. And you're doing y over r, x over r, y over x, then 1 over sine, 1 over cosine, and 1 over tangent. So for the sine, you're basically doing parentheses, negative 1/3 divided by parentheses 5/12. If you use your parentheses in both positions with the divide by sign in between, it's going to work out really clean, and you get negative 4/5. And on the cosine, if you do your 1/4 divide by parentheses 5/12, you should get 3/5. The sine and cosine are the hardest ones, but if you get those, then from there it's easy. You can either do y over x, which is what I wrote, or you can do sine over cosine, because they're equivalent, which is what I'm going to do. I'm going to cancel my 5s, and I get negative 4/3. That's really easy. Or you could do your negative 1/3 divided by 1/4, which also gives you negative 4/3. I prefer just canceling my 5s and getting it. Yeah. Yeah, because these two definitions for tan are equivalent, sine over cosine and y over x. Okay. Then for cosecant, look at your sine answer and flip it so you get negative 5/4. For secant, look at your cosine answer and flip it so it's 5/3. And for cotangent, look at your tan. You get negative 3/4. Any questions? All right, the next one we have 6 raised to a certain power and 36 to a power. You can't set those equal. You've got to change the 36 to be like 6. And y'all know that 6 squared is 36. Okay, so what we have is 6 to the x squared minus 91 equals 6 squared to the 3x. So that really turns into x squared minus 91 equals 6x, because we do 2 times 3x is 6x. This one, there's a lot of different ways to do it. You could change it to x squared minus 6x minus 91 equals 0. You could factor that. You could use your quadratic equation if you wanted to or needed to. Or you could get the 0 of the graph or the table. So there's lots of different ways to do it. What I did was I just used the table. In this case, it worked out really well because I saw negative 7, 0 and 13, 0. And so negative 7 and 13 are my answers. Yeah, I graphed it and then I did Control T. If these didn't show up, then you can trap it using the 0 of the graph. Do I need to show you all how to do that? Okay. Okay, now this one, 20 degrees, 58 minutes, 3 seconds. So we know for sure it's going to start with a 20 point something. And we do 58 over 60 plus 3 over 3600. Where I got the 3600 from is it's 60 times 60. Some people didn't quite use that, and so their numbers were close but wrong, basically. So just do your 58 over 60 plus 3 over 3600, and you get 0.9675. And this says round to 2 decimal places, so 0.97. All right. The next one, you can type it as it is if you want, and you use square root of 6 as your base and you get 4. If not, use your change of base formula, which would have been log 36 over log square root of 6, with both of these as base 10. There's different ways to do it. I know it says without the calculator, but I'm not going to take it away for one question.
On Map Excel, you're not going to
Well, it wants a fraction. That's a good question. It does want a fraction, not a decimal. So if you get a decimal, you'll have to figure out what that is. Yeah. Like basically, I'd probably just rewrite this one as 6 to the 1/2, and rewrite this one as 6 squared, and go from there. You want me to?
Yeah.
Okay. Well, if I do, we may not get through the whole review, though.
I'll just come and see what you're doing.
Okay. Let me do that at the very end, if I have time. Okay. Okay. So 33 This says form a polynomial whose zeros and degree are given. You have 9 with multiplicity 1, so that means x minus 9. And you have a negative 2 with multiplicity 2, so that means x plus 2 squared. It does say degree 3, which is what the degree we're going to be in. And remember, we noticed that on Math Excel, it would count this right. Yeah. The other way, which is what we really wanted to do, was to go x minus 9 times the expansion, x squared plus 4x plus 4, and then you get x cubed plus 4x squared plus 4x minus 9x squared minus 36x minus 36. Yeah. Again, what I wanted y'all to do is, if it's only to the third or fourth power, I wanted y'all to multiply it out, but I saw Math Excel counted it right. So anyway, x cubed, then your 4x squared minus 9x squared is negative 5x squared. 4 minus 36 is negative 32x, and then minus 36. So this would work, or that would work. Okay, number 34, we've got 15 pi over 4. So what I mentioned yesterday is you can use your denominator, which in this case is 4, and multiply by 2 pi to get 8 pi. And so we want something smaller than 8 pi over 4. Because 8 pi over 4 is what 2 pi is. So then you do your 15 fourths minus 2, because that's like subtracting 2 pi. That gives you 7 fourths. So then your answer is 7 pi over 4. Yeah, that's right. Yeah, that's right. And also I noticed that in first period they preferred using degrees, which is fine also. I want to show y'all both ways. So y'all could have said 15 times 180 over 4. And so that's really 15 times 45, which is 675. And from there, just subtract 360 instead of subtracting 2 pi. So they got 315 degrees. So we know it's not B or D. You need to be able to distinguish between A and C. This one looks like it has a 45 degree reference angle. And this one looks way too small. So it's this one. Basically think of starting here on the right, looping around one full time, because that's why we had to subtract 2 pi or 360. And then we had to end where it ended up at 315, which is right here. Okay, good. Then this one, we want our real zeros, and what you really do is just look at the factored form and change the signs. So basically just change your signs of the factorization. So if it says x plus 1/4, then it's negative 1/4. If it says x plus 2, then it's going to be minus 2.
It's okay that it's still by 3.
Yes. Yeah, those are the roots. Now, that leads me to this question. So, what those exponents are used for is the multiplicity. So, what I would do is I would write a little number line and put 0 here and -2 here. -1/4 is pretty close to 0. And so that tells me -2 is smaller. Yeah, because it's further away. And that one had an exponent of 3, so that's where it crosses. Because if it's odd, it crosses. And the -1/4 is going to be larger. It has an exponent of 2, and so it touches. And I use this information to fill out my answers. So the larger 0 is -1/4, and it wants the multiplicity. So the multiplicity would be the exponent, which is 2. And the multiplicity of the smaller would be 3. So it does go 2 and then 3. And then for the larger one, we said it touches, and the other one crosses. And you can either write those or just fill in the blank. Choose the thing. Touches and crosses. The next part is about the maximum number of turning points, and so how we always did that was the number of degrees minus 1. So if we had a degree of 2 plus a degree of 3 and then subtract 1, we get 4. The reason why it's like that is because you're multiplying, because it's basically like x squared times x cubed. So that's x to the 2 plus 3, which is x to the 5th. That's the reason. So for the power function, we know it's based on the x to the 5th. But before I write that, this is the most important part, because I know this is why some people miss it. Your original problem has -4 here. We've got to bring that down. So we get -4, and then you get x to the 5th. That's the most common mistake, forgetting to bring down your number, your coefficient. Okay, and then 36 is our last one. This one is not linear based on the numbers we see, because the numbers are increasing so fast. And what we notice is you're multiplying by 5. So here's the important thing for y'all to remember. Before we said it's the initial value times the constant multiple to the x power. But that's a little confusing for certain people, which is fine. So there's an easier way to explain it. The easier way to explain it is it's the y-intercept times the base to the x. So the y-intercept would be 6. Your base is going to be 5 because that's what you're multiplying by. So times 5 to the x. And that's going to be our equation. And make sure you do the one that's exponential if it's like this. So we get 6 times 5 to the x. I remember when we did this before, some people forgot the 6. Some people switched the 6 and the 5. So make sure you don't make that mistake. We take our y-intercept, that goes in front. The base is what you're multiplying by over and over. 6 times 5, 30 times 5, and so forth. Yeah, sure. Yeah, now that we're done with this, I'll go back to 32 and see what I can do. Okay, so if we had log square root of 6 of 36, I'm just going to say an or in front of this. What we could have done is we could have called this equal to x. And then we move this around like so, because your base for the log becomes the base for the exponent. And so then we get 36 equals square root of 6 to the x power. Then we want to change both of them to have 6 for the base. So we get 6 squared, and this is 6 to the 1/2. And then x. Because 6 to the 1/2 power is the same as the square root of 6. So now that our 6's are the same, we can say 2 equal 1/2 to the x, and multiply by 2, and we get 4. Yeah, so that'd be the other approach for number 32. Okay, good question.